This lesson is going to cover our topic on dilations. This is our learning target 1 from our unit on similarity. This learning target says I can dilate a figure when given a scale factor. So what's a dilation? Think about the word dilation in terms of your eye. To dilate your eye is to change the size of that circle that is your pupil. It gets bigger and smaller, to accommodate for the amount of light that it's entering it. A dilation is a transformation that changes the size, but not the shape of an object or figure. Every dilation has a fixed point called the center of dilation. The center of dilation really, in a big way, controls where and how the dilation gets drawn. So this is basically two opposite ideas. We're going to be expanding and shrinking different shapes. We also got to understand what a scale factor is. A scale factor is a number that shrinks or expands a shape by. We create a scale factor by looking at the two shapes. We take the image and we divide it by the pre-image. We take a measurement from the image, like 10 feet, and divide it by a corresponding part of the pre-image, which could be 2 feet. So in this problem, 10 divided by 2 is equal to 5. So this is the scale factor for this dilation. You can do this using any corresponding parts. Take the 15. The 15 is from the image, and the 3 is the corresponding part of the pre-image. 15 divided by 3 is still 5. See how these sides of both of these trapezoids have grown by the same amount. They've both grown by a factor of 5. So scale factors that are greater than 1 expand or grow shapes. Scale factors that are less than 1 shrink shapes. Now let's try some dilations of shapes so that you can get a good idea of how to do this. So we're going to dilate this triangle. We're given a center of dilation. The center of dilation is right here. We have a scale factor. The scale factor is 2. So we're going to double the size of this shape, but we want to do it precisely. To do it precisely, we're going to have to do a couple steps. The first step is to draw lines extending from the point of dilation and touching each of the vertices of my shape. So you see, each one goes through what you guys would call the corners of the shape, the vertexes of the shape, the points or the angles. Now I take a ruler and I measure how long it is from the center dilation to where it touches the shape. And I see from mine, it touches it at about 3.2. I'm also using the centimeters. I'm not using the inches, I'm using the centimeters. So from 0 to 3.2. So I'm going to double that. So this was 3.2. 3.2 times 2 is 6.4. So 6.4 is about right here. Now let's measure the next line from the center dilation to the corner or where it hits the shape. Some people want to stop and measure it right here, but this is in the middle of the side of the triangle. I don't want to measure that. I want to measure all the way to the vertex. It's hitting it right at 4.5. 4.5. So I'm going to double 4.5. And I get 9. So right there is where I'm going to draw one of the corners of my triangle. And the last measurement is 3.4. 3.4 is my last measurement. So I'm going to double 3.4. So 3.4 times 2 is 6.8. Here's 6, 6.5, 6.8 is about right here. Now all I have to do is connect these into my new triangle. And this triangle is an exact copy of the original triangle, except for the fact that it's just larger. It's still the exact same shape, it's just gotten bigger. So again, we drew these lines that went from the center dilation and touched each of the corners or vertexes of that shape. I measured from the center to each of those vertexes, and then I doubled those amounts. Let's do this, but let's have the point sitting in the inside of our shape. So from the center, I draw lines that go through each of the corners or vertex of my shape. And now I start to measure them. So this measurement looks like it hits around 13.7-ish. And I have a scale factor of 1/3. So I need to do 13.7 times 1/3. I end up with about 4.6. So I'm going to put a mark at 4.6. Then the next measurement has it hitting at 14.7. Times that by 1/3, and I get 4.9. So let's put a mark at 4.9, about right there. From the center of dilation to this corner, I get 8.4. So 8.4 times 1/3 is 2.8. So let's put a marking at 2.8. There's 2. 0.8 is about right there. And my last measurement has me at about 6. I'm going to go with 6.8. 6.8. 6.8 times 1/3 is approximately 2.3. So 2.3 would be right about here. Now all I have to do is connect those 4 spots, and I should get a good looking smaller rectangle. There we go. So center dilations that are within a shape is going to put your new shape within that shape. Also, notice that the dilation was less than 1, which shrunk my shape. So I took 1/3 of each of these lines as they hit the black rectangle to make the red rectangle. Find the center of dilation. Now this is actually one of the easiest skills of our lesson. All I have to do for this is find out where all those lines that touch each of the corners intersect. I'm going to draw a line that extends and touches both of the corresponding vertices of our shape. I'm going to do that again with the other two, and we see that these two lines do start to intersect, and do it a 3rd time so that it touches both of the corners. And I see that the 3 lines intersect at a single location. So the answer to this question of where is the center of our dilation, it's right here. Let's continue and do this one more time. So we have this corner matches up with this one. Don't forget to make your lines nice and long. This corner matches up with this one. This corner is along the same line as this, so I'm just going to draw it this way. And again, the same way, extending this one. So my center of dilation happens right here. This center dilation is actually on the edge of the two shapes. And that's about it for dilation. Understanding how to use a scale factor, what the steps are to dilate, and working backwards a bit to find the center dilations using those same exact lines. If you have any questions, make sure you write them down, and don't forget to hit the submit button.